Hello, hello. Welcome to the SNIA webcast on object storage, what, how, and why. Good morning, good afternoon, and good evening, wherever you are around the world. This is the SNIA Networking Storage Forum, or NSF webcast, about object storage. So we welcome you, and we are about to get started. This is John Kim, chair of the SNIA NSF, and your moderator for today. I will introduce our august presenters, and then we'll get right into it, and then we'll also take questions. So let me go ahead and give a brief introduction to SNIA and talk about how the webcast will work, and then we will get started. So first of all, today's presenters, we have Rick Vanover from Veeam, Chris Evans from Architecting IT, and Alex McDonald from NetApp, who is also co-chair of the SNIA Networking Storage Forum. So these presenters are going to educate you today about object storage, and they will also take your questions. A brief background about SNIA and SNIA NSF. SNIA is a leading organization focused on storage, networking, and connectivity and standards. We have more than 185 industry-leading organizations and more than 2,000 active contributing members. Our content is used and read by more than 50,000 IT end users and storage pros worldwide. You can learn more about SNIA at snia.org/technical. You can also follow us on Twitter at SNIA. Specifically in the Networking Storage Forum, or NSF, we focus on technologies like Ethernet, iSCSI, NVMe over Fabrics, InfiniBand, Fiber Channel, FCOE, hyperconverged infrastructure, different storage protocols, virtualized storage, software-defined storage, and other aspects of storage connectivity and storage networking. And now the legal notice to keep the lawyers happy. So this material is copyrighted by SNIA unless otherwise noted. Member companies and individual members of SNIA may use any of this material in presentations or literature under the following conditions. Any slide or slides used must be reproduced in their entirety without modification, and SNIA must be acknowledged as the source of any material from this webcast that is used in any document, webcast, or presentation. This presentation is a project of SNIA. Neither the author nor the presenter nor any of the presenters are attorneys, and nothing in this presentation is intended to be or should be construed as or taken as legal advice or the opinion of legal counsel. If you need legal advice or legal opinion, please consult your favorite attorney. The information presented herein represents the author's personal opinion and current understanding of the relevant issues involved. The author, presenters, and SNIA do not assume any responsibility or liability for damages arising out of any reliance or use of this material. There are no warranties, express or implied. Use it at your own risk, though we do attempt to make it as accurate and useful as possible. All right, thank you for bearing with me through that. Let's actually, well, let me advance the slide. I didn't do that. There we go. Let's go ahead and get into this webcast. We're going to talk about what is object. Oh, it looks like I might have skipped a slide just a second. All right, my apologies. Let me now turn this over to Rick Vanover from Veeam. Rick, please take it away.
Well, cheers, John, and thanks for the intro, and happy to be here on behalf of SNIA. So Chris and I are going to go through kind of a journey of object storage, and that's really the whole point of the topic today. You know, how do you use it, what is it, etc. So we'll start with the history, we'll go through some use cases, go through some market assessments, and then Alex is going to come in with some super good detail on, more specifically how this type of technology works. So let's start with what is it, right? One of the things that I can say from an object storage standpoint is that you have to really break it down into characteristics of storage. From a hardware perspective, it does go to storage devices, hard drives, SSDs, etc., that we're familiar with in the market. But there's some high-level characteristics that go along with object storage, and these were actually pulled right from the original specification of this type of technology. Things like shared access to data, heterogeneous computing, and dynamic scaling without interruption. I think those are actually really important characteristics when we think about it, because shared access to data is, in many areas, not the type of storage I grew up with. Chris, I don't know if you kind of feel the same way. Like right from definition, shared access kind of feels a little foreign at first.
Yeah. So, Rick, it's interesting because if you look at the history of the way we've dealt with storage, we've tended to see it connected to devices, connected to servers, and so on. But obviously, as we've moved on, and we'll get onto that in terms of our discussion in this presentation, we've seen a need to have more access to shared data. And as we're moving more into a cloud model, and we're putting our applications in many different places and distributing our applications, this need to be able to do shared access to data becomes more important. And that's going to be one of the aspects we talk about as we go forward.
Absolutely. And I think that you mentioned an important point there. The cloud model, this little personal soapbox I like to get on, is that the cloud is a model. It's not necessarily a location. I'm actually going to come back to that here in a second. So when we think about where did this all come from, those of us who have been in the industry a while may even remember some of the early definitions and early names using phrases like object-based storage. And as we are now, object storage has kind of been the name that's stuck. I do think there was a lot of work done in the late 1990s. Whoa, over 20 years ago now. Kind of scary. Feels very recent. But Seagate did a lot of work. And there's a couple of good resources from the original specifications, from one vendor who had implemented it. And, of course, there's plenty of other SNIA resources on object storage as well. But the one name that was really kind of a consistent theme through it is Dr. Garth Gibson from Carnegie Mellon. In fact, I reached out to Dr. Gibson trying to get a quote for him from him on this webinar. He wasn't available. He does have his hands full being CEO at Vector Institute for AI, so he's working on something really sharp. But, Chris, I know you have been in the industry a while. In fact, as long as I've been in, you were already in. What was your observation when object storage came into the market and some of the early adopters?
Yeah, I think I've been in the industry too many years, Rick, in some respects. So maybe we should step over that quite quickly. But I look back and think of how this technology came into the market, and I remember the first sort of definitions we used to see when we talked about things called content addressable storage. And we saw this idea of having objects and content you could store in a system that didn't really have any structure like a file system or a block device. And that was quite an interesting sort of approach. And it made you wonder what you could do with this going forward. So, the interesting bit there was, and this is going to be something we'll get to at some point in the presentation, is a lot of the accessibility of those platforms was via API, so they weren't as easily consumable as other types of storage, and therefore probably a bit sort of mystic in their definitions. And I'm sure we'll come on to that. We'll see how that evolved in the evolution of this technology going forward.
Well, I think that's an important part, is that consumable by API is a characteristic we have here that we're going to cover. But the important thing to know about consumability via an API is that really, if you think about the late 90s, that was a little bit ahead of its time. I think too many organizations weren't really ready for that, and the app development space wasn't really ready for that. But then this technology, object storage, especially with some of its characteristics of scalability and such, kind of fell in nicely to other characteristics in the market.
Yeah, I think
and so
I agree.
Yeah.
Sorry, Rick. Yeah, I agree. And I think just to finish that off, inevitably technologies get created and they get adopted. And as the industry changes and we see the needs for that, clearly certain technologies become more interesting at that point, and therefore we suddenly realize that actually we've needed this technology all along. And that's something I think object storage certainly got into in the 2000s as we saw that the new millennium come in.
Yeah, and that's a good point, because it did fall in right at the right time, slightly before the need was very well defined. And I want to kind of get the listeners a visual to help us kind of understand where and how object storage sits in the market. I think a lot of us, I want to say a lot of us, not everybody, I guess, on the call has started their IT practice before object storage. But I know that I grew up consuming storage in one of these two on the left here, block and file. And I think it becomes a very good way to compare object storage differently. And I want to give a quick shout out to Caringo, object storage vendor. They have this from one of their blogs. It actually is, I think, one of the best, simplest visualizations of the differences. And probably the most important thing when we mention those APIs that becomes a difference between traditional storage, or the storage we grew up with, is that the client is an application. This is a fundamental difference. You think about APIs. This is why I think object storage was really meant for the mobile era, a little bit of an internet transition, all of these different reasons. By the application being the client, this is really fundamentally changing everything from security to accessibility and more, because if you compare that particular consumption, that top box on this diagram, you look at operating systems, right? How many times have we got into discussions around initiator zoning or file drivers within operating systems? Those become kind of the consumption model, whereas object storage transitions just straight through to the application. And I mean, Chris, I think block and file are very consumable technologies for those with established practices in storage. But that particular consumption model by the application, it's a different conversation to have with storage people.
Yeah, absolutely. So think about block as being the fundamental component, almost the building block of the way you build a lot of storage systems and a lot of storage environments, persistent storage environments. They were one of the earliest types of technology we connect to mainframes and then servers, but effectively the block is not really a very intelligent device. It's very fast, it's got good random access to individual blocks and low latency, but it's not got any intelligence. So we almost inevitably in most environments overlaid a file system on there, which is, as this lovely diagram shows, added our attributes, gave us that ability to implement things like security, but typically if it was on a single server, would only be accessed by a single site. Object shifts that paradigm another step further and says, actually, let's distance ourselves from the physical media and the physical constraints of how we implement the storage, and let's start thinking about things in a more abstract way and saying that we want to actually store and retrieve objects, which could be files, could be all sorts of different types of content. We'll do that in a moment. But now we've got something where we can actually, as you said, consume data from an application, which is a very different paradigm indeed to the first two technologies.
And I think the other kind of important characteristic to observe here is that there's file restrictions that basically inherently don't happen with object storage. And what I mean by that, there's no necessarily a concept of a lock, right? There's these phenomena called eventual consistency, and there's inherently a scale-out characteristic. And then when you also think about the application being the client, you have immediately opened up an incredible ecosystem. So you can think about Windows and Linux, and you can think about mobile platforms, and you can think about web services, and even progress that further into containerized applications, right? So the consumption will completely be democratized by being in an application. And the other thing to kind of note is that I'm going to come back to this here in a second, but I think it's very important because I want to reiterate it a number of times. When we get into the use case of object storage, one of the most important things we have to think about is the security model. I think a lot of times we fell into security by application design, by storage network design in those first two columns. I think one of the biggest risks going forward with more object storage used in the market is the notion of, overexposed object storage, open buckets. We've heard those types of phrases before because they are globally addressable within, especially the hyperscale public cloud object storage. On-prem, we can have a little bit more control. But I don't know, Chris, if you've gotten any object storage security experience with some of your practice, but I know that I have worked a lot to try to advise people to take that very seriously.
Yeah, absolutely. So just touching back on some of that security aspect, I would just think it's worth finishing off the discussion that talks about the difference between file and object. And obviously you touched on the whole idea of attributes and other things that you can set when you actually build a file system. Part of that being the fact that you put in a great structure around file directories and the naming and so on. And that's great. but obviously things like locking of an individual file so that you can control who's got access to it to read or to write becomes a significant overhead, and that becomes a scaling issue, which I'm sure we'll get onto in a moment in the discussion. As we look at object stores, definitely you've got an inherently much simpler model in terms of security, in the sense that you're putting permissions around reading and writing at a very sort of basic level. We'll talk about CRUD later on in the presentation, but effectively creating objects, updating them, deleting them. That has been a real issue for people to get their head around, because in a lot of object stores, the initial default was to allow you to have completely open access to that bucket and that collection of data within that object store. And that's certainly been a big issue when we've been on the public internet, and it's something that people need to be aware of, that security is still important, but it's done differently to the way we've seen it done on other types of technology.
Absolutely, and that becomes at least at the bottom here. One of the pro tips I want to offer for the listeners is that, it's not that it's hard or difficult, it's just that it's different in how you go about the security aspect. And you could also work backwards and come back into say what type of data is actually a candidate for object storage, etc. But when we think about how it works, we talked about this consumption and the writing of object storage is done via RESTful APIs. And for me, that's an area that it's different, right? Again, you have to use applications to do that, but it's very, very much like a web standard in regards to how object storage is consumed, is written, and then also deleted. But you can also get into situations where the internet, usually the public internet, becomes one of the most popular consumption models, meaning if you think about the amount of storage available in Azure and Amazon with object storage, and then most use cases, not all, and we'll get to that in a second, but many of the use cases go for the internet. So it's almost by definition effectively unlimited. And this is something that we can think about how much hard drive capacity from a manufacturing standpoint exists in the world. And if any of the listeners are mathematicians, you can definitely call me out. Yet no, it's not unlimited. I realize there are limits, but for organizations who consume this content, it's effectively unlimited because they don't have a barrier, meaning we are going to be full, I need to add more storage when you think about the hyperscale public clouds. Now on premises, if we look at object storage, again back to the location versus the model conversation, you absolutely need to be concerned about overall consumption, but the hyperscale internet, hyperscale providers on the internet can kind of alleviate that for many organizations. But one of the other things I want to highlight is metadata. And metadata becomes kind of this new aspect of object storage, and you can think about how metadata is applied to different types of metadata, but basically object stores will basically extend this data by some attributes and filtering capabilities, which if you think about this, when you're talking about large scores of data, and Chris mentioned content addressable storage, for example, this can actually be very important to find what you're looking for, because browsing through some of these types of resources are very difficult because of the way the applications write it. Applications usually aren't very concerned about writing it nicely, and if you think about what we grew up with things like fragmentation and things like that, none of that exists here. So it's all about performance to get it in and or out quickly. And we can think about these APIs and think about metadata, think about the scale, think about the internet, but keep in the back of our mind the security conversation that always needs to be in place. Because if you're thinking about the hyperscale public cloud object storage providers, generally speaking, those buckets or containers of object storage are unique within the cloud. So what that means is the potential threat surface area is just available to the world. They know what to look for. And I think that that's kind of important to make sure that data that you consume by these APIs is protected, but then also keep in mind all of these different areas. Anything you'd want to add to that, Chris?
Yeah, I think I'd just like to go back and talk on a couple of things. First of all, the REST APIs, and then we'll talk a bit about the metadata. So from an API perspective, we should bear in mind that every type of I/O we already do to file or to block devices is already going through some form of interface or API or protocol. We already do that today, so there's nothing inherently different about that other than the fact that we're using a different type of protocol in order to talk to an object store. Now, whereas in normal operation we're used to how easy it is to write to a block device or to open a file server and access a file system, with APIs we need a little bit of help here. So typically you'll find that in most programming languages and most operations that we have developer kits, software developer kits, which will encapsulate all of the pieces you need in order to engage and actually connect to an object store to restore and retrieve data. So in actual fact, programming to an object store is not actually as difficult as it seems. So I think that's one thing that's worth just highlighting. The other one is this whole subject of metadata, and I think this is an extremely important difference from the way we look at other types of data. So imagine we use an object store to keep information like personal medical records, where we've got things like X-rays or other types of data that's been taken from machinery which scans you for various things. We can start adding metadata on that's specific to the application rather than for the storage of the data on the platform. And what we mean by that is, rather than just storing something that says when we created the file, what date and time, we can now perhaps tag a name to that, or even a hospital reference number, or we could put some data on to say which application device it came from. Was it an X-ray? Was it a medical imaging device? And we can build around that a set of rich information that we can then search, and we can pull out all sorts of really interesting pieces of statistics and results from that allow us to dig into a very large pool of data in much more effective ways than we could do if we put it in just a file system. So the extensibility of metadata in an object store is a key, powerful sort of feature that really adds value to storing data in that format.
Well, that's a good point, Chris, because you bring up an interesting characteristic that happens with that. And what I mean by that is, imagine if you had a lot of data in object storage. I've seen plenty of phenomena where if you pull or read a lot of that data out at once, it actually can be surprisingly high performance. And what I mean by that is, think about how historically file or block storage on premises, if you do this massive amount of reads or massive amounts of writes, you might implement bottlenecks and some stress on the storage network. When you think about, because of the way the metadata knows where everything is and it's inherently very distributed, you can actually have some surprisingly high performance object storage. This comes specifically from an observation I had in my role at Veeam, but I've seen people move data actually a lot faster out of the cloud for backup data than it was really, than we expected, for example.
Yeah, I'd agree. And if you look at, say, traditional protocols like NFS or SMB, those protocols were written for local area networks typically, and are fairly what we call chatty. So you see a lot of conversation going back between the client and the target as they negotiate the access to the file. And also, if you were doing hundreds of streams of the same file, you would see quite a significant overhead in managing all of those streams. Now, an object store doesn't have that same overhead and is much better at, for example, being the front-end delivery network for a content delivery system where thousands of people might be accessing the same content at the same time. And it's much more capable of delivering that stream data to many people in parallel than, say, a file system might be. And certainly you wouldn't use block storage for any of that sort of thing.
Yeah, indeed. And I think that the use cases, will be very much determined by the applications. And I think that the storage of object storage, I have my most, I guess, I won't quite say it's the most intelligent thing on the slide deck, but I'll say that the storage is still storage. And what I mean by that is all storage systems have tiers and management capabilities and different types of levels and ways to consume it. And that applies to object storage as well. So I think that these APIs, sure that they're a good thing to get your head around to consume and retrieve the data in object storage. But there's some interesting special capabilities that come with some of the different cloud providers. One of those that I'll highlight, and this list of three, governance and compliance mode, soft delete, and immutable, these exist both, not the same, but they exist in Amazon and Azure. And you also see some of this happen in S3 compatible, object storage compatible engines that can be run on on-premises object storage deployments. But let me explain what some of these are. And we might have heard of Worm, write once, read many type of data. You can loosely apply something like that to a compliance mode or a governance mode. One of those capabilities exists specifically in S3 and S3 compatible. And then Microsoft Azure, for example, they have this thing called a soft delete, which is it's deleted, but it's not really deleted until a number of days or such have passed. And then there's some immutable containers, and like that's in Azure, for example, a whole container, which is the Azure equivalent of, say, a bucket, is marked as not available for deleting. And those are a really good construct to put data into hyperscale public clouds with a few types of additional controls. There's a lot of use cases for something like that. We'll get to this notion of a golden repository here in a bit. But the thought is, within these types of capabilities, there's also tiers or levels. And this is actually very important because I think that cold and archive storages, which that's like one of the biggest mysteries in my opinion, and that is that's specifically something like Amazon Glacier or Glacier Deep Archive. These types of services have a very long retrieval process. For example, if I put something in Glacier and I want to pull it out, it's going to take a little bit more time to get out, expedited, standard, or bulk. And these are just very different types of capabilities. I would never have these types of, especially on the bottom, these types of things exist on premises. But when you think of the different levels and tiers and capabilities, Chris, what other types of thoughts around object storage kind of come to mind?
So what you're demonstrating there, Rick, I think in this slide is you're talking here about the life cycle of content as it goes through creation to being accessed by somebody to then being archived or maybe kept for future use and then maybe retained long term in case it's ever needed again for some sort of analytics or analysis. And clearly things like governance and compliance are part of that because as you create certain documents, for example, you might want to ensure they're never ever touched once they're created. And they may need to be kept as they are for a time limit that says we need to keep that object locked for the next 5 years, for whatever logical reason. Inevitably, if you're creating large volumes of data, you need to look at it and apply service levels to it around deciding how long you keep it on different cost or different tiers of storage from a cost perspective. And the idea of archiving off to different types of back-end storage gives us that capability to optimize the cost. Now, the good thing is that in most object stores, especially those that are based in the public cloud, these things are delivered to you as a service or a feature where you can set a policy around your data and then have the system in the background do that movement automatically for you. And obviously optimize cost as part of that. But I think ultimately what we're showing here is that data has a lifetime. It has a different set of requirements during that lifetime, and the object store can deliver to that changing requirement over the life of that data.
Yeah, that's exactly right. And there are different data use cases that would use that cold archive. They would use the governance, compliance, immutability, et cetera, but not all. And, if I think of like a media distribution service, right? Everybody is familiar with a couple of the large television services that use object storage as a content delivery network. I definitely wouldn't want those on the bottom because who wants to wait 1 to 5 minutes for their show to start, right? Nobody wants that. So the thought here is that different types of data can sit in different types of service levels within object storage as well. And my tip here is to actually be very careful on this because sometimes if you think about the different capabilities, different service levels beyond what I would just call standard or infrequent access type of storages, or hot or cool, etc., you run into different costs. And for example, things like the retrieval costs from this archive engine, you're paying very little for it over the long term, but it's really, if you pull it all out, not only do you potentially have to wait some time, but it can have a pretty high cost. And we'll get to costs here in a second, but my recommendation to the listeners is to be very specific on which service level of object storage you consume for certain types of data.
Yeah, can I just finish up on that one, Rick, and just add a little bit to that?
Yeah, sure.
And that's just to say that, clearly one of the things that we talk about when we look at object storage is that they're designed for potentially billions of objects and even petabytes worth of capacity. So although not everybody has that level of data to store in an object store, you pretty much can't put it all on one tier of storage from day one. So as you look at the business case for deploying an object store and then how you actually implement that object store within your business, you definitely have to look at the policy requirements as to where data will go at different points and what different types of data might have different use cases. And this is where things like the code in the archive can be very useful. But obviously there are the capabilities of delivering storage at a higher cost, but obviously faster response times to the user. And to be fair, that's also the same for the on-premises guys, who will allow you to build technology that uses both flash and hard drives to deliver the same sort of implementation.
Absolutely, and that's a characteristic you do not have in the public cloud with that level of granularity in regards to the control of what happens to that. So that's actually a very important point. So when we think about object storage, yeah, sure.
Sorry, quick question. Actually, there are two questions. One's a cost question, but I'll put that off until a little bit later because I think you're going to talk more about cost. But one question is, how do current customers define the common metadata format when you have a variety of data which are hard to group? So maybe you could talk a little bit about that. You have different people, different types of data have different kinds of metadata. How do you define that for object storage?
Well, I'll start with my perspective, and I think it goes back to the app that will be writing or consuming this object storage. And then you have to also go and think about which object storage engine, because we'll get to that here in a second, but they're all not the same. And they actually have some significant variance, especially if you go and compare, say, Google Cloud Object Storage to S3. They're very different. Or if you look at the on-prem object storages, they're very different. But I have to work backwards to the application to set that common metadata. But industry-wide, that's a different construct. But it really comes down to the applications.
So yeah, just to answer that one from my perspective, metadata is effectively just a key value pair. So you say, here's my definition of what the data is I'm keeping, like it might be a name, or it might be, the time of day, or it might be an application name. And then there's the actual value which goes along with that. And you can attach metadata to any object. So you can be very unstructured and create different metadata for every object, but that would be crazy. Whereas, as Rick said, typically what you want to do is you want to be creating metadata that ties to that application. And that application will actually be the structure around how you build that metadata. So that's something that you would be expecting your developer to tell you that they wanted as part of the design of that application.
Yeah,
very good. Thank you.
Cheers, John. And keep the questions coming. Well, here they come. That's great. But I also think it's important to know what is and what is not good use cases for object storage. And, content distribution for something consumable like those video services, those are a very good example. But not everybody is doing that, right? Not everyone is making Netflix-type applications and services, right? And then on top of that, if you're like a business, you might even use a service that's doing that for you. But then I think there also are plenty of use cases around cloud-native applications, building services around object storage, which may or may not be, known, but it is necessarily using object storage. But anything that's needing high transactional access or low latency or immediately consistent data, those are not good candidates. And sometimes running operating systems is like a good example, right? You just don't do that on object storage. You might be able to through gateways and technologies like that, but it's not generally a good use case for it. And again, I mentioned that there's a lot of other SNIA resources in the mix about this, and one of those is another transactional models webinar that you can check out that was done in 2017. And I think that, use cases it's really hard to give a good list of what is and what is not a good use case. But, Chris, do you have any potential ideas of, a good use case for object storage and maybe one bad use case for object storage additionally?
Yeah, so I tend to think of object stores as being great for content where the object itself rarely changes internally. So that sounds like an odd description, but I'll explain what I mean. So imagine you create like an X-ray scan, or you collect some seismic data from a device that's sitting in the field in an oil rig. If that data is collected as a collective, an object, and then stored and never actually modified, that's great for an object store because you're storing things that literally are a fixed objects for its lifetime. Think of things like media or video that doesn't really change that much. Those sort of use cases are great for an object store because typically the next time that object is created, it's created again in its entirety, or maybe it's a completely new object anyway, so you don't sort of overwrite that object continuously. Now, something that wouldn't be so good in an object store would be something where there's a lot of updates to the data and where you're changing that data in various pieces within inside itself. So imagine putting a database onto an object store. That would be a terrible idea because ultimately within a database you update individual components and even parts of files within that database structure, and that wouldn't suit an object store in any way whatsoever.
Well, that's a very good point because a database from an application standpoint is going to have its own organization construct, whereas object storage, for one, with metadata can actually provide some of that. So I think there's going to be people out there making quote-unquote databases in object storage buckets or containers, but it might not be SQL, Oracle, et cetera, per se type of database. And another good, I think, yeah, definitely not a mainstream database. But the other kind of good candidate for something in object storage is, like you said, Chris, something that doesn't get changed. And it's actually important to note, I believe all object storage implementations, I don't think any of them have the notion of a modify. I think it's only write or delete. I know that's the case in some of the hyperscale public clouds. But when you think about consuming that storage, the whole notion of a modification, right, if it's not even there, granted applications can work around that, but that I think becomes an interesting construct or ground rule of sorts to work with, because that will fundamentally change how you might even think about consuming the individual unit.
Yeah, I agree, Rick, and I think I'm fairly sure that, and I can't remember whether it was Amazon or one of the cloud providers, did provide the capability to do partial updates on an offset of an object. But in general, the design of object stores and the way they work and the way that they store and track objects that you store, they're pretty much designed that when you update the object, you update the entire object, and either you create a new object or you replace the object completely in its entirety as part of the way that you would then access it.
Yeah, it comes down to the put and the get. And if we put an object into the store and we get an object, we could put a new one, right? And that would basically take a similar concept. But it's, again, a different set of primitive commands that we have to work with that makes it kind of a different type of conversation. And, I would be remiss if I said that object storage was only the hyperscale public clouds, because it's not. And sure, Amazon and Azure, I don't know the exact amount of data that are in those two hyperscale public clouds, but it's a lot. And there are other options, though. I think there are plenty of mainstream storage vendors that have implemented object storage. And in my professional experience, I don't know, Chris, your take, but I actually see a lot of the on-prem storage platforms with object storage implemented as well.
Yeah, let's just bear in mind that if you are building an object store on premises compared to one in the cloud, if you're running in the public cloud, you will pay egress charges for accessing that data as you move it out of the public cloud in terms of access. You'll pay for access generally as well. So you really need to consider that if you've got an environment where you potentially might be moving a lot of data in and out or moving it around, there's not just the cost of storage, there's the cost of access. And sometimes sometimes end users might be looking at it and saying, it might be a better model for me to keep all of my data on premises and only push data into the cloud when I need it there for access. So there's some really interesting use cases around whether you should do stuff on-prem or not, actually. And it's not straightforward. It's really application and business dependent.
Oh, you're hit on a very important topic, and I think that the economics of this are really important. And we have that covered on the next slide, but the egress charge is a very, very unique phenomena to the hyperscale public cloud. I spoke to a large automobile manufacturer who is aggressively going into the smart vehicles market. So it's actually amazing what you can do with your smartphone app and your car, things like starting the car, diagnostics. This is great. And if you think about the amount of cars and the amount of people with smartphones, it's a huge market. People want these type of technologies. I have it with my wife's car, and I love it. But I spoke to that particular auto manufacturer, and you know what they did? They actually pulled this application out of the cloud. It was too much egress that it actually made it not economical. And they run that application on-prem on a unified storage system with object storage support. So these types of surprises can be discovered, partially the hard way. But another example to kind of look at that is some of the smart appliances. I spoke to a organization that makes like aircon units, and they said over the life of a individual unit that they make, it'll cost around $20 every year for the smart device, and just in cloud costs and API calls and things like that. So, when you think about the economics of the internet, someone that I know likes to say the cloud is not a charity, and they're absolutely right. But there is a certain comfort in using the cloud. I mean, there's a lot of infrastructure you don't have to maintain. It's a pretty big decision. Which way do you go? Do you go with the public cloud? Do you go with on-prem storage? But I think in either way, an important safety concern is that object storage is durable. And I grew up in a time when I was very focused on things like RAID and things like that. But erasure coding is a durability technique that is more suitable for these large storage systems. So anything you'd want to add about kind of some of those types of considerations, Chris?
Yeah, it's interesting you started off this discussion, Rick, talking about Garth Gibson, who obviously was one of the founders of RAID in the first place. So maybe that was part of the reason why he was involved in this idea, because he was looking at whether there was better ways to actually protect data. But just to touch on the erasure coding is really quite an interesting one, because it not only protects the data at scale, it typically gets better at scale, and also it gives you the ability to protect data across geographies without having to add replicas of data that we would traditionally do with, say, block and file. And that's quite an interesting difference for customers who might want to be presenting the same data in different locations in their own data centers. So rather than doing it in the cloud where you just access directly in the cloud, this would be saying, I want to put this technology in my own data centers, but I need it accessible across 4 locations. Erasure coding would allow you to do that much more efficiently than replicating multiple copies, and it will keep it all in sync. So that's probably another good reason why you might want to look at an object store as a way of providing consistent data across many sites within an organization.
Yeah, indeed. And I think that, go ahead.
I think we have 2 questions that might be appropriate here, because the one that I thought was about cost is really more about size. In fact, both questions are about size, and I guess where does size matter in the cloud and in object storage? So the first question is, what is the minimum size of data store below which object storage becomes inefficient and maybe it makes sense to use block or file instead. So I think they're sort of saying, that question is really asking, do you have to have a certain minimum amount of data store or a certain size of data store before it makes sense to use object storage? And the other question is, are object sizes a consideration on whether or not you should use object storage? And is the use of NoSQL databases related to using object storage? I guess that's sort of asking, if I use NoSQL database, does that mean I should also be using object storage? So you could take those two questions.
Let me pick the first one.
Go for
Rick,
it.
shall I pick up the first one? Yeah. So in terms of size of an object store, or even size of objects within an object store, typically, let's talk about size of objects within the store. There's no real issue there. You could have large objects and you could have small. And your object storage platform should be able to cope with both. In terms of building a solution where you're worried about how much capacity you should start with for an object store, I would say that if you're building something on premises, you're typically talking about tens or maybe 100 terabytes plus in order to build something like that, simply because you need a minimum number of disk drives, controllers, redundancy, and so on. But if you go to the public cloud, there's no real minimum there. You can just start and use whatever you like, and it could be a few hundred megabytes, it could be a few terabytes. It doesn't have to be that much because the cloud provider will simply charge you for what you use, and it's on shared access anyway.
Yeah, and I think I would add that these questions are actually quite related, and I'd say that the minimum size of data, it actually comes down to, I think, the more important decision, how are you going to get it out? Because getting it in is really straightforward, but getting it out, especially if you need 1K of data, but it's anchored around a terabyte of something else, the egress can come back and get you. So that's one other consideration I would add.
Yeah, and the other question I think was related to the idea of NoSQL. I would say that NoSQL is still a structured data concept in that sense. So if you look at, say, MongoDB, or if you look at Redis or any of those sort of key value stores, they're still a structured concept, and they're probably more useful if you want to store and retrieve individual objects where you need to be providing search capabilities, or you need consistency, or you need some sort of ACID compliance around that data because you're storing transactional information. So typically you're not looking at an object store as a transactional store for data compared to, say, a NoSQL platform, which would still give that transactional consistency.
Excellent, and thank you. I was just saying, I think we should go on with just watching the clock. Maybe we should go on with the slides, and we'll get to the other questions later.
Yes, well, we will. Keep them coming. We'll go into rapid-fire question mode at the end here, and we're almost there. So kind of as we prepare some slides here to wrap up, why does the market need object storage? Some of these examples are just made for rich media, some of those types of services. But, if there's a need for effectively unlimited capacity, that's a candidate, as we were kind of discussing. But this golden repository, this is one of those long-term retention or cloud native application type of constructs. That's a candidate. It's one of those things also. I talk to organizations that have developers on their staff today. How do they build their applications? They're going to build it in the cloud because they can have the quickest time to market with some of these services. And then at the end of the day, they need to put stuff somewhere, and the cloud object storage engines are a good candidate for that. And then the other thing, we talked a bit about cost. There is a job title, by the way, called a cloud economist. If there's organizations that are investing a lot in the cloud, having some modeling, kind of you think about these questions that we just had, what's the best type of data, best size of data to get in and out of the cloud? Doing models based on that are actually very, very important. I was speaking with a developer where I work, and they actually dissected API calls, egress charges, and did the math and modeled it out, and actually determined that if you write the data with a certain size, you will get into a more efficient angle of being able to store and retrieve data. So think about modeling and doing cloud economy types of analyses to help organizations go into the cloud with the best type of economics. Anything you want to add on that, Chris?
No, I think that makes sense. Let's carry on, Rick. That was good.
Well, great. And the other thing I'll highlight here before we hand over here to Alex is just, reminding that some of these services like S3, the simple storage service, is proprietary to Amazon, and object storage is RESTful based. And then the other part would be that the other side of these interfaces, and I don't know, Alex, if you want to jump in on some of this, some of these cloud data management interfaces can really help organizations, consume these different types of cloud services.
So I just, thank you. I just wanted to really quickly talk about standards, because that's the thing I love most about this industry, is the only way it works is by having standards. We talk about co-opetition, that's competition with cooperation, and I think that's a key thing in this area. And really the standards that we're looking at are de facto like S3, which is part of a larger Amazon ecosystem, or CDMI, which is actually an ISO standard that SNEA developed. But they all have something in common. They're all RESTful. In other words, there's no state. And that brings me to an important point when we start talking about the way they're implemented. They're all based on HTTP. Most of them are JSON, or at least just HTTP request-based. And CDMI in particular provides CRUD operations. That's create, read, update, and delete. And the update, and somebody asked a question about, can you lock records? The update's unusual. The update is actually not a true update. The update is what Chris was mentioning. It's actually a write something new for the same key value. So in other words, if I want to update a record or an object, I actually have to replace the entire thing with the same key value. And that's a slightly different mechanism of update. You can make it look like update, but it's not truly update. The other thing you can do is remove it entirely. So you can just have create, read, and delete, or create and read, and just simply have stores that grow forever, that don't necessarily have any ability to change or delete the data that they've been given. So, and you can get a very high level of security by using things like ACLs that we're all fairly accustomed to. So there were just a couple of other points I wanted to talk about in terms of standards. One of the reasons for having these kind of standards is a new type of thing we're looking at the moment in SNEA called computational storage. That's where we're moving the compute down to the data, down to the device. So the device has a certain amount of compute on it and can actually do its own work locally on the data that it has. Now, can you imagine a storage device, a smart one, that can tell you when the metadata for, let's say, the key value is color, and you've asked to be informed when there's a red one arrives. And you're actually using the computational device to interrupt you, to come back to the processor and say, somebody's just written a record that's got a color of red. You asked to be informed. And that stops us from having to do the thing that we traditionally do when we're processing large quantities of data, which is to read it all, right to the center, process it, and then throw 99.9999% of what we read away because we really didn't need it. We were just looking for the color red. So these kind of standards, and in particular things like CDMI, help us when it comes to interfacing with things like smart computational devices. And if you think about an object store as being lots and lots of devices with the computation at the front end, and then think of computational storage devices simply being small stores with local processing, then really you can see that this standard covers, regardless of where your data is, and regardless of where your compute is, you can actually provide similar, in fact the same interfaces to the objects that you have at any scale. And I think that's the key thing about standards. The other thing I like about standards, you get pretty pictures. And this picture is attempting to demonstrate that you can treat an object like anything. And in fact, CDMI allows you to treat objects like LUNs, file systems, databases. The object can be absolutely anything you like. And it provides a whole bunch of data management over the top of it as well. It's not just about creating the stuff, reading it, updating it, and deleting it. It's also about where it's placed, how it's fragmented. Perhaps I have bits of my object here and other bits somewhere else. The use cases for this as well in terms of standards, if you think of the number of clouds that we currently have in terms of the technologies, data movement between clouds, or at least having applications be able to address clouds uniformly, is becoming increasingly important. And CDMI provides that consistency. And there are many systems out there, actually. People think, CDMI, never heard of it. S3 I know about, but CDMI, never heard of it. Go ask your vendors. You'll find there are a large number of vendors support CDMI, and that their S3 implementation is, in fact, just a subset of the CDMI implementation, which is the way we like to think of it. CDMI is a superset of all the other object technologies you might have come across, because of the way that we can build these shims into our underlying object data. So that's really what I like about standards. It allows us to do stuff uniformly. It allows us to do stuff that's quite novel, and effectively allows us to talk about object storage as a class of data without having to worry about too much about the individual details of how we get access to that data. And that's me.
Okay, well cheers. Thank you for that, Alex. Appreciate that. And, John, do we want to highlight a couple of these other resources? I think attendees can download the slides real time. There's a lot of links both here and throughout the deck.
Absolutely. Attendees can download these slides right now. They can also watch the replay. And these are the slides have these links that you see here, which include some previous SNIA webcasts, either from SNIA NSF or the SNIA Cloud, it was Cloud Storage and Technologies forum, which talk about cloud storage, object storage. So some of these have been posted on YouTube, and you can also see the link to the Cloud Technologies forum. So let's see here. Shall we dive into the questions? And okay.
Yeah, let's go right into them. Let's go right into them. Yep.
Yes. All right. So one question is, for many people, I hear that object storage is equal to slow storage, like for backup and archives. Is it possible to have object storage that is high performance? And if so, what would be a use case for high performance object storage?
Well,
Okay.
given that I'm in the backup industry, I think that that's a misconception. I am not seeing that, at least from retrieval and from ingest. That's not what I'm seeing, but I'll let Chris kind of give his perspective as well.
Yeah, so think about object stores as a different way of access. So typically you're accessing an object where you read the whole object in across the network. So you're going to be concerned about time to access of that first byte of the object. How quickly can I get to it? So that's your latency. And then you're going to look at throughput. So how quickly will that object stream to me afterwards? Those are the things that become the important metrics. You can absolutely get object stores that are based on all-flash storage and therefore a high performance. And we're starting to see object stores be used more in things like ML and AI, where we need to be able to read data very quickly and frequently with low latency in order to do our analytics. So yes, absolutely, you can have high-performance object stores.
Okay, great. Thank you for the great answers on that. The next question, this might be for Alex, so it could be for all of you. The object storage on-premises, I assume that means like in private cloud or on-premises cloud. How can you get insight into like quota usage, who has consumed what, or audit the data access for data leaks, who has accessed what? Is there a tool, or perhaps an API, for understanding and managing object data solutions?
The answer to that is twofold. Yes, and they all vary. Certainly, it would be really nice if there was a standard way of getting this, and CDMI helps to a degree, but there's the issue that a lot of vendors provide these kind of management interfaces as separate and quite distinct and proprietary in their nature. So it very much depends. And I'd like to see more. I mean, one of the things we've done in a lot of standard areas is try and provide management interfaces that are uniform. And it would be nice to see more uptake by the industry. I think that's something that customers ought to insist on. You know, if I'm going out there and I'm buying an object storage device or service, are your interfaces for those management practices that I need to undertake, are they standardized in some way? And if the answer is no, I think you need to insist on making sure that the vendors at least give you some promises about where they're going in the future with these kinds of technologies.
Excellent. Thank you, Alex. All right, we have another question here, and you mentioned it, you referred to it earlier, and it's a question about basically, does NetApp Storage Grid or perhaps other NetApp products offer some way to lock data, make it sort of worm or something like, well, object lock I guess is specific to Cloudian, but some way to make the object storage data immutable?
Talk to a salesperson, not me.
Okay, but I guess the general answer is that it varies from vendor to vendor, but more than one cloud storage vendor offers that kind of ability, I think.
Most, if not all, actually offer the ability to remove the update and delete functionality simply by using the security facilities that most of them provide.
And if they don't now, they probably will in the next firmware. I mean, the threats of ransomware and those types of things are pressing the storage vendors to have that full stack implementation for sure.
Absolutely.
Another question is, I believe object storage could be enabled with versioning capabilities. Is there any limit on the number of versions for a particular object?
No, don't CDMI.
Yeah, you'd have to check the per object storage engine implementation, but especially if you think about, put your head around the cloud, the hyperscale public clouds, they actually want you to consume more. That's why some services don't have limits, because they want you to consume more and they want to charge you for every element of it.
Okay, very good. And maybe we'll have time for one more, just reach the top of the hour, and then we'll answer the rest of the questions in a blog. So we always make sure, if any questions we can't get to here on the webcast live, we go ahead and try to answer them in a blog, but we'll publish 1 to 2 weeks after this webcast. So maybe the last question, at a high level, how would you differentiate on-premises based object storage solutions from public cloud-based object storage?
Well, I'll start.
Go
ahead, Chris. Okay, I'll go. So I got 2 points, and then Chris 2 points. My big difference is you're not going to have egress, and then you'll have full geo control of the data. Those are 2 very important differences. And I'll give Chris some input too.
Yeah, and I would look at it and say that in the cloud you're paying per capacity and for access, and you let the vendor in the cloud do all the management on your behalf. On premises, you have typically a bit more flexibility around setting your own policies and how they're implemented on the technology, so you can control your own costs a little differently, but you do have to then manage the infrastructure yourself.
Okay, very nice. So Chris, Rick, and Alex, thank you very much for a wonderful webcast. We have run out of time, but as I said, we'll answer the other questions in a blog. Let me just wrap up here. So I guess let me back up actually and wrap up. So in the summary, we've covered the history of object storage, what it is, how it works, why it matters in the market, how you access it, some of the good use cases, and standards like the standard Alex talked about for, I think it was a CDMI. And then we had our questions, and I would like to ask that everyone on the audience please go ahead and rate this webcast. And you can rate this within Bright Talk and give us feedback. We'd love to hear that feedback on what you thought of the webcast. As I mentioned, the PDF is already available here in Bright Talk. It will also be posted to the SNIA NSF website, and it will be available on demand. You can go to that website and find it and then watch the replay. All of the questions will be put into a blog, and you can generally see the questions and answers and links to our previous webcasts if you go to the SNIA NSF website. You can also follow us on Twitter at SNIA NSF. I think with that said, a big thank you to Rick, to Chris, to Alex, and to everyone who has attended today. And we look forward to seeing you on the next SNIA webcast, which I think we'll be having in March. All right, everyone. Thank you very much, and goodbye.